In this video, we'll be talking about trig functions. Let x, y be a point other than the origin on the terminal side of an angle theta in standard position. So let's sketch that. I'm going to have the terminal side in quadrant 1, but it doesn't matter. So the point xy is on the terminal side of the angle theta, so this is my angle theta, in standard position. Now the distance from the point to the origin we call r, and r is, using the distance formula, x minus 0 quantity squared plus y minus 0 quantity squared. So r is given by the formula square root of x squared plus y squared. The 6 trig functions are defined as, let me draw the x is here and y, so this length is x and this is y. Sine theta, we abbreviate that as sin, or sine theta, is defined as y over r. Cosine theta, abbreviated as cos, is defined as x over r. The tangent theta, abbreviated as tan, is defined as y over x. Now the next 3 trig functions are the reciprocals of these 3. So the reciprocal of sine is cosecant theta, and that's abbreviated CSC, and that is going to be the reciprocal, so r over y. The reciprocal of cosine is secant, the abbreviation for secant is SEC, and that will be r over x. And the reciprocal of the tangent function is cotangent, the abbreviation for that is COT, and that is defined as x over y. Our reciprocal functions, I know I need to remember that the sine starts with an S, and cosecant starts with a C. Those are the reciprocals of each other. It's not what you would normally think. The reciprocal does not also start with an S. So you need to remind yourself, I guess. So the S sine and the C cosecant are reciprocals. And then the C cosine and the S secant are reciprocals. And then tangent and cotangent those are pretty straightforward. Okay, let's do an example with our trig functions. We're asked to sketch an angle theta in standard position such that theta has the least possible positive measure and the given point root 3, negative root 3 is on the terminal side of theta. So let's plot that first, and then we'll continue reading. So root 3, and then negative root 3. It's going to be down in quadrant 4. So we had to go right, root 3, and then we had to go down, negative root 3. And this is our terminal side of our angle. And theta is going to be least positive measure. So this is our theta. We can use the reference triangle to help us solve the problem if we need to. But by definition, we should be able to just use our x value and our y value. And then we'll need our r value, so let's go ahead and calculate that. R is the square root of x squared plus y squared. So our r is the square root of 3 squared is 3. And negative square root of 3 squared is 3. So r is root 6. And now let's continue. It says, then find the values of the 6 trig functions and rationalize the denominator if applicable. So, sine theta, cosine theta, tangent theta, reciprocal of sine cosecant theta, secant theta, and cotangent theta. Sine is defined as y over r. Cosine is x over r. Tangent is y over x. Then cosecant is the reciprocal of sine, so r over y. Secant is r over x. Cotangent is x over y. So our sine theta is y, negative root 3, over r, root 6. This is negative root 1/2, which is negative root 2 over 2. If we rationalize, Our cosine is x over r, so root 3 over root 6. Which will be root 2 over 2. Our tangent is y over x, so a negative root 3 over root 3. Root 3's cancel, so this will be just negative 1. Cosecant is r over y. Root 6 over negative root 3. This will simplify to a negative root 2. Secant is r over x. So root 6 over root 3. And again, root 6 is root 2 times root 3, and the root 3's cancel. So it'll be just root 2. And cotangent theta is x over y, so root 3 over negative root 3, which is negative 1. Okay, let's look at another problem with our 6 trig functions. We're told that 3x minus 2y equals 0, where x is less than or equal to 0, is the equation of the terminal side of an angle theta. Sketch the smallest possible angle theta and find the values of the 6 trig functions. Okay. First of all, let's look at our equation. We have 3x minus 2y equals 0. Let's subtract 3x from both sides. So negative 2y equals negative 3x. And then divide both sides by negative 2. So y is equal to 3 halves. So this is the equation of our terminal side. We can put plus 0 on the end here if we like. We know from y equal mx plus b that the y-intercept is 0. And we're told that x is less than or equal to 0. So we want our x to be less than 0. So this is our terminal side of our angle theta. This will be theta. And our point is negative 2, negative 3. We're also going to need to find r. And r we know is the square root of x squared plus y squared. So r is 4 and 9, so square root of 13. Alright, let's sketch the smallest possible angle theta, find the values of the 6 trig functions. Okay, so we're ready to do that. Let me list my trig functions. Sine theta, cosine theta, tangent theta. The reciprocal of sine would be cosecant theta. The reciprocal of cosine is secant theta. And the reciprocal of tangent, cotangent theta. Sine is defined as y over r. Cosine is x over r. Tangent is y over x. Cosecant is the reciprocal of sine, so r over y. Secant is the reciprocal of cosine, so r over x. And cotangent is the reciprocal of tangent, so x over y. Now let's just get our ratios and we should be good. We want y over r. Y is -3. R is root 13. And when we rationalize the denominator, multiply top and bottom of this ratio by root 13, we get -3 root 13 over 13. Alright, we need cosine theta, which is x over r. So -2 over root 13. Rationalize this denominator, we have a -2 root 13 over 13. Now for tangent theta, we need y over, we can just cancel those negatives and get 3. Cosecant is the reciprocal of sine. So I can just take this ratio before I rationalized it and find its reciprocal. So I have a -root 13 over 3. Alright, our secant is the reciprocal of cosine, so I'll find the reciprocal of this ratio. That'll be a -root 13 over 2. And then our cotangent is the reciprocal of tangent, so it'll be 2/3.